My name is Kristen Weaver. I am the Deputy Coordinator for the Globe Observer Project. We are very excited. We are counting down to the eclipse that is coming up in less than 3 weeks. And tonight we are going to hear about the globe eclipse aspect, the clouds aspect of it, specifically related to the challenge that we're doing surrounding the eclipse about clouds and our solar powered Earth. And so we have with us here this evening Marilé Colón Robles, who is our project scientist for Globe Clouds down at NASA Langley Research Center in Virginia, as well as Ashlee Autore, also down at NASA Langley, who is doing some research with us. She looked at some of the annular eclipse data from October and is getting ready to look at our total solar eclipse data from April 8th. So without further ado, Marilé and Ashlee, take it away.
Thank you, Kristen. Hello, everybody. Thank you for joining us. I hope you know that we've started a new eclipse challenge, the Globe Eclipse Challenge, Clouds in Our Solar-Powered Earth. Let's look at this video quick, and then you'll get to talk to us and ask us some questions. The sun drives many processes in Earth's atmosphere. As the sun rises and sets, it warms Earth's surface at different intensities. These changes in heat lead to changes in the clouds, especially the types of clouds. To study these changes, we need observations at different times throughout the day, week, month, and year from the same location. Changes can even be observed during astronomical events like a total solar eclipse. Use the Globe program's Globe Observer app to observe how clouds are changing.
Hi, my name is Ashlee Autore, and I'm a scientist at NASA Langley Research Center. I'll be analyzing the globe eclipse data, looking for changes in the atmosphere. You can help me by taking measurements of cloud and air temperature an hour or so before and after the eclipse.
Participate in the Globe Eclipse Challenge, Clouds in Our Solar-Powered Earth, from March 15th through April 15th, 2024. Awesome. So now you all know we are in the challenge time. We would love for you to go outside, make some cloud observations throughout this time period, and to study how clouds are changing as the sun rises and sets with that very special date, Monday, April 8th, 2024, which is the eclipse. So again, my name is Marilé Colón Robles. I'm the project scientist for the Globe Cloud observations. And with me here in a second will be Ashlee Autore, who is our data scientist and web developer for the My NASA Data project. But she's been looking at your observations for the annular eclipse and excited to get observations for the total solar eclipse now in April. And now, like we saw in the video, there's going to be changes not just on the amount of light, but also around you as the moon covers the sun. Sun gives us light and gives us heat, and that heat is the one that warms the ground and produces that heat that comes up and produces clouds. So we are expecting a coolness in the temperature, also some disappearance or some of those clouds to kind of disappear or dissolve out as that energy from the sun starts getting covered by the moon. And then that can also, those changes in temperature because of what's happening can lead to some wind pickup, which is called the eclipse wind. So we're also interested in just anecdotal observations of the wind. You can also put a wind stick out and take pictures to show us about that eclipse wind. So we really want to study that and see what's happening. In order to understand more what might happen, let's go through a little bit of what we talked about in our blog. And so we went through the 4 main ways of having or forming clouds. One is the convection, which the sun heats up the ground, and then the air right above the ground heats up and then starts rising, expanding, and then at one point it'll condense. Those water vapor forms into water droplets, and then you'll have a cloud. These are those puffy cumulus clouds that you might see behind me hanging out in my background or in the image. So as you're experiencing the eclipse, these puffy clouds are one of the ones that you'll probably see dissipate or disappear as the eclipse occurs. And you don't have to be in the path of totality to see this happening. It's been observed at 40%, 60%, 80% totality. So you don't have to be in 100% in the path to see these changes. Another way of getting these clouds, and for those of you that live near mountainous, I'm from Puerto Rico. This is why my name is in Spanish. One side of the mountains is always raining. You always see the clouds. The other side is always dry. So what the mountains are doing are pushing that air up. And as that air rises, just like in the previous example, it'll expand, condense, and then you'll have the clouds. As the air goes down the mountains, it warms up. So it's the opposite. And that's why you don't have clouds in that side. And you can have even windstorms. In Colorado, you have a lot of windstorms on that side of the mountains, which are exciting for those of us that like weather phenomena. The other type that might dissipate are these cirrostratus clouds. So this is a picture taken by somebody just like you, but the Globe Observer app. Convergence. Think of air coming together. Just like people converge, air can converge and then rises up. Now this rising of the air is not, doesn't produce a lot of instability. So it won't produce a thunderstorm or a puffy cloud. Cumulus clouds, the air inside of it goes upward, and that's why you have those towers. If a cloud produces this convergence, it'll be very thin, very flat. So cirrostratus, cirro for thin, high clouds, which are always made of ice crystals. Stratus is a cloud that's spread in every direction. So you might see some of these cirrus clouds dissipate. When my colleagues and I were in Albuquerque, New Mexico last year for the annular eclipse, we saw some of these cirrus clouds disappearing or dissipating as the eclipse occurred, which was really interesting. Now, the other type is due to fronts. So think of a front as a big push of air upward, and then it'll create this instability. For us weather geeks, this is the most exciting type of cloud formation. Imagine a cold front is very steep, so the air pushes really fast upward, and ahead of the front is where you have the severe weather, the thunderstorms, those supercell thunderstorms especially. Those are the ones that produce those strong tornadoes. A warm front is not as steep. It's more kind of like an incline. So you won't have that much of severe weather. You'll have more of the stratus type clouds, and that's why you have the rain that lasts for a few days and it's constant rain. You see that in the winter time. You won't have that drastic push up. I bring this up because we are in spring, just like we see in the chat. There is some severe weather going on. So even as safety, just keep aware of the weather that's happening. But I'm going to play this video. This is a dry line. So a dry line is kind of like a special type of front that happens a lot in Texas and in Oklahoma. A front is a barrier or boundary between two different air masses, right? Usually cold and warm might be the ones that you're most used to, but it could also be moist and dry. So think of Texas, that southern part of the US. That dry air comes from the north, from the mountains, from being dragged through the Rockies all the way south, and it hits that super moist air from the Gulf. That is a dry line. So that's where you get the severe. So I'm going to play this quick video so you can see that development of the cloud. Now you can watch the rest of the video within the blog post, but it's exciting, but also something to keep in mind of when you're out, might be out. Another reminder is that for every cloud observation that you make through the Globe Observer app, we'll match it whenever possible to satellite data, and that includes the GOES satellite data, which we were just watching a video. Now, again, some of the cloud types, especially those small clouds and those cirrus clouds, are the ones that are going to dissipate or disappear during the eclipse. This is a neat video. I'm just going to show part of it. Again, this video is also on the blog post, but it'll go fast, but it'll show some of these small convection. So when we're looking at this image, you have really big convection, lots of cloud cover. You can see those towers growing. And so when I'm looking at a satellite image, I'm looking at, this tells me that these cloud tops are growing. So this is a really strong storm, the same over here. These around here are small, the small cumulus clouds, and lots of cumulus clouds over here. Could be some cirrus clouds, cirrocumulus clouds. What is going to change? This type of storm is not going to change because, again, that's, I'm assuming, I'm going to take a really good guess that this is frontal. This is a front that's passing, that's pushing that air up. So if you turn off the sun, if you block the sun, very little change will happen because all that energy is being pushed by the front. Now, these small ones around here, those will probably were developed by that heating, and those are the ones that are going to change. So I'm going to play it. Again, it's going to go fast, but you can watch it in the app, in the blog post as well. So I hope you were able to catch a few of those clouds kind of like disappearing and then coming back. That's what we're really interested in. Again, you can watch this on the blog, but I am going to pass it on to Ashlee Autore, who made some analysis from your observations. And thank you for those that made observations during the annular eclipse. Ashlee.
Yeah, thank you. And thank you everybody for being here and making observations in October. And I'm looking forward to having more in April for this total eclipse coming up. So I hope everyone has the app downloaded and ready to go. All right, so the October eclipse happened October 14th last year. It went through North, Central, and South America. Globe received 2,300 citizen science cloud observations worldwide in more than just North and South America. We had some over in Europe too, which is really cool. But I only looked at the just over 2,000 observations that happened in the eclipse path. That image on the right shows where the eclipse was. The center path is in yellow, and you can kind of make out where that goes, where it started off in Oregon and down through and exited through Brazil. Those red lines are percent totality in 20% increments. So from the center, you have 80%, 60%, 40, 20, and then 0. And anything out that I didn't consider for the project. Not yet. So most places experience the eclipse for about 2 hours. So from start to end, depending on where you were, of course, that time changed, could have been less if you were further away from the center path. And the eclipse, it took about 6 hours to go through that whole path that it went through. And all of those black dots there are places where we received citizen science observations. So you can see we actually had a pretty good spread, and we had a lot in America, of course, but Brazil had a good amount as well. This map is from NCEI. It was their projected viewability map before the eclipse happened. They used historical meteorology data to come up with a map of where they thought good places to see the eclipse would be. So the clearer the dot, the white, means that they expected them to have good viewability, whereas the darker spots meant it's likely to be more cloudy. So with this in mind, we can compare what NCEI thought people were going to see to what our citizen scientists reported they actually saw. This here is an image of the ghost imagery from the day of the eclipse. On the left, we have ghost west. You can see the west coast of the US and a little part of Alaska. And then on the right, we have ghost east, showing the rest of North America and South America. So this is just scrolling through from 1400 UTC to 2200 UTC, just so you could get a view of what the cloud behavior looked like on the day of the eclipse. Here is just some map of where we had our observations from, just to give you a little more of a close-up. All of the black points were citizen science observation sites, which I've denoted as CS from here on out. So those were all the people with the Globe app or using the website reporting their own observations. The blue triangles are data spots or sites from ASOS stations. So typically ASOS, which are automated surface observatory systems, those are most likely at airports. They're weather stations that are looking up at the sky and telling us what they see. So I have a good spread of citizen science observation sites, and I tried to choose ASOS sites that were in locations near a good amount of citizen science observations. That way I could compare them and see what was in agreement, what wasn't. So here is our first map showing us the citizen science cloud changes. So from the time of the eclipse started, and a little bit before, I looked an hour before the partial eclipse started at the local location, to an hour after it ended, I used the citizen science observations and looked at how they reported the clouds changed during that time. The green arrows pointing up indicate a cloud increase was experienced, red arrows pointing down mean a decrease, and then the blue dots mean they saw no change. So overall, there wasn't too much of a pattern yet. That's because we only had, like 2,000 observation points, and we couldn't use all of them because some of the sites only had one observation. The more observations we get at a site, the more analysis we can do, because then we can compare how the clouds are changing over time. But what this does show us is that we have citizens willing to take data and willing to move to where the eclipse is happening. So you can see we had some good observations right along the center path of the eclipse because people chose to go there. And here are the ASOS cloud changes. So I did the same thing an hour before the eclipse to an hour after the eclipse ended using the ASOS site data. So the ASOS sites look straight up at clouds. They don't look around like the people do. So the citizen scientists are instructed on how to take a good cloud observation. But the ASOS sites are going to do it differently. They look straight up at the sky, whereas citizen scientists are looking around and reporting what they see around them. So it's going to be a little bit different, and we're using this to get a whole big picture. So having what the ASOS sites are seeing helps us understand what the sky's actually looking like, but then the people are showing us what it is in a whole big picture, not just at one single point. Again, no real pattern, and you can see that we have a much tinier spread of ASOS sites than we do the citizen scientists, because the citizen scientists were moving, whereas the ASOS weather stations can't really just pick it up and move it as you want. Now we're bringing in another element. This is the same cloud analysis from an hour before to an hour after the eclipse, but here we have climate zones incorporated into the map. So we have the cloud legend, or the climate zone legend, right there in the top right corner. And you can see with the citizen scientists, we covered every single climate zone, which is super cool. There are 8 climate zones in the United States. It's recognized by PNNL. And we had good representation from every climate zone, even subarctic and very cold. So it's really cool seeing us have some observations in Alaska. But you can still see no real pattern. But we might get a pattern looking at the April data. This here is the ASOS data with the climate zones incorporated. So the ASOS sites, we actually didn't get every climate zone. We didn't get very cold. Now that there could be other weather stations reporting the cloud coverage, but I didn't get an ASOS site specifically, and that was what I considered for the October eclipse. I do plan on finding more weather stations and doing more analysis with April, but with the data we had, this is what I was able to do so far. Again, you can still see no clear pattern even with the climate zones incorporated. So if I'm using the weather station data still, why is citizen science data important? Well, that's easy. If you didn't get it yet, that's because citizen scientists can move. They cover more spatial area and they can cover more temporal areas as well. So whereas the weather station can take, 5-minute increments, and the data I use, the ASOS 5-minute reports, they're 30-minute averages. So it's not just what's happening exactly at that time. It's the average of what has happened. Whereas these citizen scientists, they're going to move to where the phenomena are. They're going to move to where we want to receive data for small phenomena that are happening just in a short amount of time. Because, eclipse, if you can see the total eclipse for about 2 minutes, a weather station might not pick that up, but the people will. And then it just gets people involved and excited about science. Without having the public involved, without having them excited, we're not going to make as many advancements as we possibly could. Now, this is to help get you excited about the April eclipse. In case you don't know where you're going to be yet, or you don't know the exact path of the eclipse, here it is. This is released from NASA. You can see the path, the total center path of the eclipse going through from Texas up through Maine. So hopefully you plan to be somewhere near that. But if not, just about the entire United States is going to be in some percentage totality. So you will experience a partial eclipse no matter where you are. And that's really cool. So now I think I pass it back to Marilé.
So if you have the Globe Observer app on your phones, on your smart devices, you are good to go. Okay. Today, apparently, yes, is that true?
I just checked. Yes, it came out just a few hours ago, I think. So
okay.
the Eclipse tool is in practice mode in the app now. So you can if you have Observer, make sure you might need to close the app and then reopen it. But you should see the Eclipse tool now in practice mode. So yes, it's in there.
So if you see our camera views, you'll see the eclipse portion. We call it the tool right there. So you'll see it right there, and you can start practicing your observations, which is really good to do, so that there's going to be so many emotions, at least for me when I observed the 2017 total solar eclipse. I was doing the observations, but I was also going through the emotions of being the first total solar eclipse for myself. And it was a lot to do, right? With the cloud observations, and then the clouds were dissipating, and I'm like, oh my gosh. As a scientist, I knew what was happening, but still the emotions of what was going around me and seeing the animals and then the street lights come on, it was a lot. So use the app. You can practice right now, make your observations. If you make cloud observations, we're going to love it because we love receiving cloud observations. Those go into our database, and then we do statistical analysis of what's happening around the world. Remember that we have our Eclipse challenge going on as well. Now, we wanted to bring a few items to your attention. These are a few of my favorite things. I might start singing. It's going to be okay. But one of our favorite projects is another citizen science project called Eclipse Soundscapes. And why I love it, I know, Rebecca, I love your face. It's because, yes, the clouds are going to be disappearing. Yes, the temperature is going to get colder, but the animals around you are also going to have some experiences as well. So you can also jot those down. So let me play this short clip about eclipse soundscapes, and you can find more information about them at go.nasa.gov/eclipse.
During a total solar eclipse, it is almost like day becomes night very quickly.
So knowing that there's going to be a change in that light and life-giving energy means that we can predict when animals are going to have a rapid shift in their behavior,
which results in changes in the acoustic environment or the soundscape.
So the Eclipse Soundscapes project is a project to determine how eclipses affect life here on Earth.
And there's a lot more to observation than just what you see. It's also important to think about what you hear.
We're measuring how the rapid onset of darkness during an eclipse affects wildlife by measuring the changes in sounds that they make.
The general public is best suited for this type of project because the general public is everywhere.
And that's really the power of the participatory science component of this project. It enables recordings and observations of soundscapes across the diversity of ecosystems covered by the path of totality. We might think of some ecosystems having a greater influence of human activities on the soundscape, whereas in other ecosystems, say a remote part of a national park, we might have a lower influence of human activities and greater influence from the sounds of life.
Awesome. So I hope that that gets you excited as well. The Eclipse Soundscapes, if you have an audio moth, you are in for a treat to help them out. If you don't have an audio moth, it's going to be okay. They'll need also people to analyze the data afterwards. So you can still be a part of the Eclipse Soundscapes, even if you're not collecting the data. They'll need help afterwards as well. Now, if you allow me, I'm going to geek out a little bit. These are a few of my favorite things. Sing with me, right? Okay, so I saw this at a NASA Science Live yesterday. If you did not know, we might even see a comet if you're in the path of totality. So look at this picture. We're looking at the south during totality. So between those 2 and 4 minutes of darkness, you should be able to see Venus, which is the brightest thing right in the sky, apart from the moon and the sun. Saturn and Mars, note that they might be faint. Jupiter, Mercury, which is extremely hard to see, but I love to try and catch Mercury. But look right above that is the comet 12P. And not to get you too excited, because comets are very tricky if you try to observe comets like we've done, we meaning my family and I. But there is a chance that it might break off part of its ice. So comets are dirty ice balls, right? They're ice in dirt, and it comes apart, and when it comes apart like that, it creates these glows. So if it creates a glow, then it might be visible with the naked eye during the total eclipse. Okay, I'm just a little bit excited, right? 3 weeks, are we like 3 weeks to go? Okay. Second, there is a map from the SIMS, which is through NOAA, and NASA is about to release their map of the amount of the mean cloud fraction by looking at multiple years. And so this does not mean that you will see this amount of clouds on this day. Remember the difference between weather and climate. I'm from Puerto Rico, and I moved to Illinois to do my master's degree in atmospheric sciences. That was a change in climate, people. I went from 80 degrees year round to like -20 to 90 degrees difference. So I'm not kidding you. I spent $1,000 on just getting clothes, because the clothes in your wardrobe or in your closet is climate. What you pick for that day is weather. So let me say that again. The options that you have to wear are based on the climate. I did not, and I say that again, I did not have the right clothes to live in Illinois from coming from Puerto Rico. Puerto Rico, if you don't know, is an island in the Caribbean, which you would love to visit. There's beautiful beaches and wonderful food. But anyway, I had to spend $1,000 on shoes, being able to walk in ice, these coats where my face was completely covered. That is climate. What you pick is weather. So this is the climate. This is what usually happens looking at multiple years. What will happen at that day? We are to find out soon enough, right? Now, Gus was a great example about severe weather. I wanted to bring this chart, which is amazing. I don't know if you noticed, but the topography of the United States makes it so unique that it's the one place in the world that has so many tornadoes. No other place in the world has this amount of tornadoes per year on top of it. You might have 2, 10 in other locations like in Europe and things like that, not 1,000 as your annual average, okay? And so just pointing out, they released this since 2022, the National Weather Service under NOAA, on the number of tornadoes per state. And I think you can put right there where you might be, right? I'm going to be in Niagara Falls, so 9. I'm not, it's not going to be that exciting versus like Texas, Oklahoma, Illinois. I used to storm chase when I was in Illinois. So just bringing this, make sure that you always have safety, not just on viewing the eclipse, but also just in case it gets a little bit exciting, not just because of the comet. Make sure that you have a safe place to go. And then I found also this location, and we'll put the links on the chat, on the number of storms on average, which is that dark gray line, and then what we have right now in March in red. So again, all this is available in National Weather Service site. Just a reminder that things are going to be happening on the ground and in the skies. So we hope that you go also and visit our Globe Eclipse Challenge page. You'll find how to participate during this time period with that special day on April 8th. But we don't want you to stop that day. We want you to go on. The challenge continues until the 15th of April. You'll also find videos and information about clouds and other projects. And como has escuchado, yo hablo en español también. So we've made everything available in Spanish as well. And a lot of the resources are in French as well for our French Canadians friends who will experience the eclipse. There's also different resources and toolkits depending on the groups that you might experience. And so I'm going to pass it back to Kristen Weaver and see if there's any questions.
Yeah, and we've had a lot of conversation happening in the chat, but no, I haven't seen questions yet. I mean, the big question was that, yes, the Eclipse tool is now in the app available. If you don't see it when you open up the app, try whatever you do to hard close your app. On iPhone, that's sort of like swiping up and closing it and then opening it again, and that should trigger it to check for an update, and then you should get the update. And if that doesn't work, you can also try, make sure you send in any data you have stored, but delete the app and reinstall it, and then it definitely should. But it should just by closing it fully and opening it up again. The other thing I will say, just to explain, there was some comment about the practice mode. So what that means is that when it's in practice mode from now until April 1st, you can go through the Eclipse tool and do the air temperature measurements and practice doing that, but the data doesn't go to the GLOBE database yet. Now, clouds and the other tools, they are just as normal, so that data is going into the GLOBE database. All the usual tools go into the database as usual. It's just the air temperature data in the Eclipse tool that right now is just in practice mode, so is not actually going into the database. But then on April 1st, it will be live, and then that data will go into the database from the 1st to the 8th, and then it goes into a review mode after the eclipse. And if you're having any technical issues, maybe Holly, you can put the Globe Observer help email in the chat. It's globeobserverhelp@lists.nasa.gov. But if you're having any problems, there's also a contact us button on the Observer website, observer.globe.gov. So if you're having any technical issues, or I see someone commenting about having trouble creating an account, please reach out to us. We can help troubleshoot that. Absolutely. If you have further questions about Globe Eclipse, join us for a Q&A session on the 2nd of April 2024 at 12 p.m. Eastern Time. Learn more and register at observer.globe.gov/go-connect.